Hello. Today I'm going to be talking about my investigation on circuits and how I found all the values for the resistors. For my first resistor, I had my givens of the battery at 65 volts, and I used the total resistance equation of each resistor is added together to get that total resistance, to get a total resistance of 60 ohms. Next, I divided 65 volts by 60 ohms using Ohm's law, which is one of the equations of I equals V over R, to get a current of 1.083 amperes. This is going to be the current for the whole system because there's only one pathway, and regardless of the different resistances, that current will stay consistent throughout. Next, I solved for the voltage of that resistor by using V equals IR, another component of Ohm's law. In this case, I plugged in the current and the value of the first resistor, which is 18 ohms, to get a voltage of 19.5 volts. With that in mind, I used the voltage as well as the current to find the power. And the power is going to be P equals I times V, which is going to be 19.5 volts times the current. So that gives us a total of 21.06 watts for that power. Next, for my second resistor, I used the same equation for the current because it's going to be the same throughout. I used that to then solve for the voltage, which is going to be the resistance of 32 ohms for this resistor, multiplied by that current of 1.083 amperes, to get a total of 34.67 volts for that resistor. Next, I used that voltage to find the power by using the given voltage I just found and the current of 1.083 amperes to find the wattage. In this case, it was 37.55 watts. For my last resistor, I used the same overall resistance because I knew that the voltage, overall voltage, was going to be divided by that overall resistance to get the current once again, which is going to be the same throughout the circuit. So in this case, I used that current value to find the voltage for this resistor, and I multiplied the current by the resistance of 10 ohms to get 10.83 volts. Next, I used the voltage that I found to find the power, which is current times voltage, and I got 11.73 watts. So those were my three components for each, or 3 to 4 components for each of the resistors that I found. Along with that, I wanted to talk about power specifically and how it affects the bulbs. We know that power is equal to voltage times current. In this case, I was asked about the brightness of the bulbs and how the power is kind of linked to that. We have already found the 3 wattages or power amounts for those 3 resistors. For our first resistor, our power was 21.06 watts, and it had a resistance of 18 ohms. Keep that in mind, and I'll explain why in just a minute. For our second resistor, we had a 32 ohm resistor with 37.55 watts, which is greater than the previous wattage listed. Lastly, we have a resistor of 10 ohms, which had an overall wattage of 11.73. This tells us that the higher the resistance, the higher the power, because the more resistance there is, the more power is needed, the brighter the bulb will be. With this being said, it can also be seen on the simulation that we used for the project, as well as in these calculations, as I mentioned, with having the greatest resistance of 32 ohms, that had the largest power. So in this case, the power of the light bulb, the greater the power, the more well lit or brighter the bulb will be. In other aspects of this, we can look at the voltage. If our voltage is increased, then our other components of the circuits will increase as well. So with that in mind, I'm talking about current. Because we do have those Ohm's laws, which voltage is equal to that resistance times the current. So if we see an increase in voltage, that means we're going to have an increase in the resistance and the current of the circuit. which is kind of that relationship within the circuit.